Okay, we're going to start by reviewing a few terms: opposite, adjacent, and hypotenuse. We have at the very top two special triangles that you learn about in geometry. One is the 30, 60, 90 triangle. One is the 45, 45, 90 triangle. Please make sure you have those down on your paper along with these primary trig functions. And these are abbreviations for them. This is pronounced sine, cosine, and tangent. I do want... Oh, excuse me. Thank you. I do want to review three key terms that I saw students consistently in a different class get confused with. So I'm going to just draw a triangle up here, and I'm going to put random numbers. We're going to say this is 3, 4, and 5. This is angle A, B, and C. So here are the terms that kids got confused with yesterday. If we're going to analyze angle A, and I said what side is opposite of A, it would be like taking a baseball and directly throwing it across. We would say side 3, that has a length of 3. This is, length 3 is directly opposite of A. The second term students get confused with is the word adjacent. Every angle that is not right, so we have two angles that are not right. Every angle that is not right consists of two sides that make an angle. So A consists of these two sides. B consists of these two sides. We are only looking at the angles that are not right. This is a right angle. So when we decide which side is the adjacent side, it can never be the longest side, known as the hypotenuse. So the adjacent of A is 4, and the adjacent of B is 3, because these two sides make B, and it can never be the longer of the two sides. And lastly, what is the hypotenuse? It's directly across from the 90 degrees, or the longest side, which happens to be 5. Okay, the next ones, we say this is cosecant, secant, and cotangent. They are the secondary trig functions. These are primary, these are secondary. Now, each one of these is the reciprocal of the primary to the left. So this is really 1 over sine, or we could say it's hypotenuse over opposite. Secant is 1 over cosine because it's the reciprocal, or we could say it's hypotenuse over adjacent. Cotangent is 1 over tangent, or we could also say it's adjacent over opposite. We're going to get started with the first problem. In your notes, please write this down. So we are going to identify all 6 trig functions along with putting that value in proper form and making sure it has the correct sign. So where do I find 300? Because we do need to be, as we sketch this, as exact as possible. So I'm going to count to 30. 3, 6, 9, 12, 15, 18, 21, 24, 27. Here is 300. From the origin, you're going to draw straight out to that dot, and then here's the key. We're going to go always directly back to the x-axis, and always to the x-axis. Directly back to the x-axis, and when you go back, you have to create an angle that's a 90-degree angle. So it's going to be perpendicular. Now, I'm going to redraw this triangle. And my question for you, bless you, is this interior angle right here? I want to know, what is that measurement? Remember when we had the pink and the green triangles, and I first was telling you about the unit circle? This was pink, 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 right? These are all pink. Every pink has an interior angle of 30. So here's 30. 30 and 30 is 60. 30, 30, 30, added together is 90, right? So your pinks, or like I was just counting in terms of pinks, all have 30, 30, 60, 90, 120, right? So to get all the way around from here all the way to here is 300. I want to know, what is this remainder? So what is that distance back to the x-axis? Well, if an entire circle is 360, and I've just gone around 300, what is this piece? It is 60. So let's just draw a little arrow here and put 60 degrees. I know that this is a right triangle, and that the interior angles of a triangle add up to 180. So if many of you could do this in your head. If not, you're going to go 60 plus 90, 60 plus 90, and then we want to know, what is this remainder? So when I get that amount, I'm going to subtract it from 180, because the interior angles of a triangle add up to 180. This is 30. Okay, next, we're going to take this. This will be on the board, or I'll give you a cheat sheet. You don't have to memorize this, but you have to know how to use it. I'm going to go, okay, across from 60 degrees is always radical 3. So I find 60 degrees directly across is radical 3. Across from 30 degrees is always 1. Across from 30 is always 1. Across from 90 is always 2. And maybe you want to circle those so they stand out. The angle we're going to evaluate is always the interior angle, and part of the line is going to always be the x-axis, never the y-axis, always the x-axis. So let's write this down. Sine, cosine, tangent, and now the secondary trig functions, cosecant, secant, and cotangent. On the board, you're going to see the acronym All-Star Trig Class. All-Star Trig Class. This tells us where we can find positive values. All means everything in quadrant 1. Everything in quadrant 1 is positive. In quadrant 2, All-Star Trig Class means only the sines are positive, only the tangent is positive, and only the cosine is positive. All-Star Trig Class. So I just landed in quadrant number 4. Quadrant 4, what's the only thing that's positive? The cosines. So let's go over to cosine and make a positive cosine, and it's reciprocal because they'll always have the exact same sign. So cosine and its reciprocal, the secondary trig function, are positive. Everything else gets 1 negative. Everything else gets 1 negative. Okay, next up. We are going to create a ratio, and we're just going to follow the directions. So sine, I come back here. What do I need to do for sine? I need to look at, we have 3 different sides, and the order that I choose them matters. The top has to be opposite, the bottom has to be hypotenuse. Okay, well, what angle are we talking about? It's this interior angle right here. So opposite is radical 3, and hypotenuse, which is opposite of 90, is 2. Cosine, well, what are the directions for cosine? Adjacent over hypotenuse, in that order. Okay, adjacent would be 1, hypotenuse is 2. Tangent, tangent means opposite over adjacent. Okay, from this angle, opposite is the square root of 3, adjacent is 1. Mathematically, those are all right, and they're also proper. And what I mean by proper, if we compare it to writing a paragraph in an English class, you always want to start with the first letter of each sentence or each question starts with a capitalized letter. The same thing here, and that's proper. Or you end each statement with a period, right? We end each question with a question mark. Well, to be proper in math means that mathematically you are right, but it also means your final answer has no square root in the bottom, the denominator. This doesn't have a square root in the denominator, I circle it. Doesn't have a square root in the denominator, doesn't have a square root in the denominator. Okay, we're going to go over here. Now, remember I told you that these two, they're related. They're the exact same sign, and all we're going to do is we're going to take the reciprocal, which is flipping them. So I'm going to flip. I'm going to write 2 over negative 3. These two are related. I'm just going to flip 2 over 1. These two are related. I'm going to flip 1 over the square root of 3. Now, all of that is mathematically right. Like everything we've done so far is right, except it's not.
Students will need a purple pass to enter class.
It's not proper. And you're like, what do you mean it's not proper? We can't leave this as the final answer because I have a square root in the denominator. So there's a shortcut to this, and I'm all about shortcuts. The shortcut is take this value and throw it up top. Okay, throw it up top. Well, what goes in the bottom? You're going to rewrite this value in the bottom, but don't put a square root there. These two are equivalent. So if you watch here, so mathematically this was not wrong. Negative 2 divided by the square root of 3. That's not mathematically wrong. Look at how this is exactly the same. Please watch. Negative 2 square root of 3 divided by 3. Notice that these are exactly the same, but this is in proper form. This is proper because there's no square root on the bottom. Just wait, please. Just wait. I have to check things. Okay, up here, I'm going to move this up. This has to have a negative. So positive, positive, negative, negative. These need to be negative, negative. So this is -1 square root of 3 over 3.